All right. So welcome, everyone. Thank you for joining today. For those of you who are not familiar with who I am, I'm Filomena Servideo Italiano. I'm the president and CEO of the Colorectal Cancer Resource and Action Network, a national patient advocacy group dedicated to championing the health and well-being of Canadians touched by colorectal cancer, and most certainly others at risk of developing the disease. Our goal is to always identify and address the unmet needs of both the metastatic and the non-metastatic colorectal cancer population so that we can help improve the longevity and quality of patients' life. Our aim is to deliver our services with compassion and care at all times, because most of us at CRAN have been through the journey as either a patient or a caregiver, recognizing that the disease is fraught with many challenges, isolation, and loneliness. So we support, we educate, and we advocate on behalf of colorectal cancer patients across Canada, which is why we supply a sea of services. Here's our team, ladies and gentlemen. We have a wonderful, wonderful team at Colorectal Cancer Resource and Action Network, one of whom is actually new, relatively new anyway, and that is Sheila Verhage Brown, who's our National Patient Programs Coordinator, who's actually joining us today and will be joining every third Sunday of the month as our support person, who's dedicating her time and energy to helping each and every one of you. Once we actually, just before we start with Shania, I'll actually give her an opportunity to introduce herself, because she'll be interacting with you on a fairly regular basis. You know, someone actually pointed something out the other day. They said to me, Filomena, you have a female dominant staff. And it didn't occur to me that I actually do. I thought, yeah, we do, but we don't look at gender. We don't look at race. We look at competence, and we look at compassion and the ability to deal with our patient population with a heart full of love and a heart full of expertise at CRAN. So, before I actually introduce Shania, I would kindly ask you to mute your screen. Shania will be accepting questions from the audience at the end of her presentation. We ask that questions actually be taken at the end of the presentation by you just raising your hand, or you can submit via the chat function at the bottom of your screen. Today's patient education session is being recorded for your convenience. The link to the session will be sent out via social media and email as well. And we'll actually be sending out a session evaluation form for your kind feedback. So, who is Ms. Shania Leduc? Besides being the Director of Business Development at OncoHelix, Shania Leduc is an oncology consultant who focuses on strategic development of programs and projects, both small and large scale. As a consultant, she offers her 27 years of clinical and commercial oncology experience to science-based and industry clients to support their evolution of medical treatment and diagnostic standards available in Canada. Shania began her career as a clinical oncology nurse coordinator of phase 1, 2, and 3 clinical trials at a large academic cancer center and managing multidisciplinary patient care across hematologic and solid tumor types. In 2000, she transitioned into the biopharmaceutical industry into sales and marketing roles for oral and IV chemotherapy agents and biologic products. Shania has been an oncology strategic consultant for the past 14 years, supporting program development of oncology science programs, such as POET at the University of Calgary. Commercially, she has supported multiple oncology therapeutic brands and biomarker implementation programs. She is passionate about building a strong, integrated, cross-functional platform that supports the successful adoption of novel treatment and biomarkers within the oncology market by sharing her expertise in biopharmaceutical marketing, medical clinic advisor, and stakeholder relations among medical associations and patient advocacy groups. In 2019, Shania started a joint venture, OncoHelix, that enables excellence in cancer comprehensive genomic profiling. As Director of Business Development, Shania is proud to have OncoHelix provide a Canadian-based access solution for exceptional clinical-grade cancer genomic profiling testing, utilizing gene panels designed for tissue or blood specimens. OncoHelix facilitates genomic profiling access via direct pay for patients, partnerships with research groups, and sponsored programs with pharmaceutical industry. Ladies and gentlemen, I have a personal connection to Shania. I have known her for several years, and in that time, I can tell you that I have actually learned from Shania. She is patient-focused, patient-centric. Her goal, her ultimate objective is to see the improvement in every patient's care when it comes to their cancer across multiple tumor types. She's passionate, she's caring, she's loving, she's compassionate. She is the ideal patient advocate, and she takes all of this and she combines it in innovative project management. It is absolutely my privilege, my honor to introduce Ms. Shania LeDuc.
Oh my goodness, Philomena, you are very good for the for the ego. I thank you, my friend. And I always love when Phil invites me to speak for CRAN, because I love the passion that CRAN patients have, and I know that you find the information, you know, helpful and inspiring, and I hope to inspire. So I hope we'll do that. And Philomena, I just discovered the other reason besides the Zoom filter for making me look younger, and it's the fuzzy image picture. I have to get you a better picture. Oh my goodness. Tricks of the trade. Okay, so you're giving me
so
control here.
I'm just going to bring it up for you, Shania.
Okay.
And you sharing privileges. Okay.
Perfect.
So here it is. And you are now shared. So you should have, there you go.
I think so. I think I'm working. We'll put it to full screen.
Yep. Hold on. There you go. Okay.
I think so. All right. So, well, good morning from Calgary, or good afternoon in the east, and all parts in between, sea to sea. You know, thanks again for having me. My name is Shania LeDuc, and yes, it's been a privilege to be able to work with Philomena and her CRAN cast for many years, and on many other projects. So I definitely love feedback, and I definitely love questions. So please let me know if there's anything that, you know, really sparked something today, or if there's things that I went through maybe a little too quickly or not in enough depth, and we can definitely see what we can do to address it. I don't have all the answers, but if I can come back around and follow up later with some more information to take back and bring back to Philomena that she can bring back to the group, I'm happy to do so. And it's nice to see some familiar faces that I've also interacted with Philomena's group. So today we're going to talk about how is the world of genomics, you know, working through all the different aspects of detection and management of colorectal cancer. And oh, Phil, I'm not able to advance the slide unless we have a little bit of a delay there.
Try it again, Shania.
Okay.
No. Let me try again. Okay, go ahead.
Okay. Maybe I'm nope. Can you advance it? Because I can just let you, I can just say to you, you can.
That's so weird. So what I'll do is this. Let me get out of here. Stop sharing. Okay. I'm going to give you sharing privileges. See, it's checked off. And then I'll bring it up again. Okay. Where is it? Go ahead. Try now, Shania.
All right.
Sometimes you have to click twice.
Oh, okay, let me try it that way. Did that work?
No, that's so weird. It works from my end.
Okay, so I'm just going to say, Phil, please advance screen. That's what we'll do. So go back. I think we have to go back a slide or two.
Yeah.
Yeah.
Okay.
There we go. Okay, so we'll go to Philomena. Next slide, please. There we go. Okay, we were at the right slide. Okay, so let's start with some of the technical science stuff, and I'll try and make it not so complicated because, you know, science people just honestly, sometimes I think they like to make it complicated to make themselves look and sound better than it needs to be. But what is ctDNA, or liquid biopsy, right? So we're talking about cell-free DNA. So when we think about a cancer tumor, it is a physical solid mass, right? But cell-free DNA is pieces of that mass that actually can be in circulation. So it's a slightly solid, but it is not in terms of a large mass that you would see on a CT scan or an X-ray. Cell-free DNA or ctDNA can't be seen on conventional imaging like an MRI or PET scan, for example, in its single little molecular form. So we call it molecular because it's at that cell molecular level. Circulating tumor DNA is found in your bloodstream, and it refers to DNA that is actually broken off of cancer cells and tumors. And what we find is most of that DNA is actually in a cell's nucleus. So we can actually extract that through a blood sample and then be able to pull out all of the elements in a blood sample to be able to find that DNA. But what happens in that tumor, as that tumor grows, it actually has a cell life cycle, just like our regular healthy cells. And when those cells die off, they slough off. And when they slough, they get broken down into the bloodstream, and then we can capture them as these sort of small circulating pieces of DNA in the bloodstream. If you've had metastatic colorectal cancer and you're just starting chemotherapy, we tell you to drink lots and lots and lots of water, and you may feel kind of really like garbage for the first couple of cycles. The chemotherapy is actually breaking down those cells, and it's circulating through your system, and you're actually excreting them out. So that's in kind of a macro form. In the micro form, cells are constantly sloughing off of cancer, whether it's the tiniest little bit of cancer or it's a fairly significant tumor size. Doesn't matter. There's always that sloughing scenario. So if we look at the diagram on the right, you'll see, like, you know, squiggly, and you'll see, you know, some DNA complex, and then you'll see a little yellow group. And I'm going to actually, Philomena, I'll get you to advance the slide for a second, and I'll get you to hit it again one more time. So circulating tumor cell is really what we're looking for, because we use sometimes these terms interchangeably, but they actually do have specific meanings. And so we have cfDNA and ctDNA, cell-free DNA versus circulating tumor DNA. I'm going to go to the cell-free DNA first. The cell-free DNA is more like just DNA strands. It's a broader term that sort of describes DNA as it just floating and circulating through the bloodstream, but it's not necessarily cancer in origin. So we know that we have DNA circulating through our blood cells that determine the color of our hair, the color of our eyes, if we're going to be short, if we're going to be tall. That's cell-free DNA. That's just our regular DNA that's doing its job in our cells. Circulating tumor DNA is truly what we're talking about when we're talking about ctDNA and the application of colorectal cancer. And it is tumor-derived fragments of DNA that's broken off or sloughed off of the actual originating cancer, and it goes into the bloodstream. So I just want to make sure that we're not confusing ctDNA from cell-free DNA. So ctDNA is the right thing to say, circulating tumor cells. So we take a blood test, we spin it down. Phil, I'll get you to advance the slide. We spin it down into different plasma and aspects of the blood sample. And then from there, we can pull out what's actually a normal cell-free DNA versus what is actually that circulating tumor DNA. And within that also has some RNA as well. And then we take those from spinning it down, and we then extract those DNA cells and then put them through a sequencer for genomic information. Versus traditional using tumor extraction, instead of what you see in a blood tube, we would actually take a piece of tumor, put it in a liquid formula to be able to then extract the DNA from there. So that's circulating tumor cell, ctDNA. That's what we're talking about. Next slide, please. So how can ctDNA be used then in the management of colorectal cancer? So we have two types of ctDNA genomic testing. We have one that detects. And when I say detects, I'm seeing. I want to be able to see what is going on at a molecular level. We can see when we look at a CT scan, an X-ray, an MRI, a PET scan. So it's kind of like that imaging, but we're imaging specifically for tiny little molecular cancer cells that otherwise they're too small to be detected otherwise with our conventional diagnostic tests. So that is sort of the detection. And there's different applications that we can talk about that. And then Phil, I'll get you to advance the slide. And then the second way is that we can use it for when we have a diagnosis of cancer. What is the genomic profile of that tumor itself? What are all the combinations of mutations and alterations in that cancer tumor that made it malignant, that made it aggressive, that made it metastatic? All of those mutational, that package, that profile can then help us determine what is the right tailored treatment for your particular cancer. So they're very two distinct uses, and we're going to go through all the uses within the colorectal cancer journey today. But when we talk about genomics, it's not just one or the other. It's this whole breadth of different uses for diagnostics with many different sort of clinical situations. So we'll go to the next slide. So let's apply this practically speaking and clinically around the whole colorectal cancer experience, from diagnosis to metastatic disease. So this is a build, Philomena, so work with me. So first we start with asymptomatic screening. So this is really all about the same situation as colonoscopy. When you're, at a certain age and you want to start, and you have to start doing your screening for colorectal cancer, because we know the earlier that it is detected, the better chance that we can have to cure. Next build. We can also use it for the prediction of cancer recurrence. This is particularly specific in the adjuvant setting, can we predict if your cancer is ever going to return or not, or if surgery was enough just to cut it out and it's good to go? Or do you actually need that extra cleanup chemo to be able to really determine and give you that extra assurance that that cancer will not recur? We can actually predict if your risk, if you need chemo or if you don't need chemo, using genomics and ctDNA. Next, then we can look at cancer surveillance monitoring. So you've had your surgery, you've had your chemo, you've had your radiation, you've had your initial treatment, and then you're being followed and watched. That's, your yearly colonoscopies, etc. Well, we can also look at that at the micro level and use ctDNA for that surveillance monitoring. Next build. And then we can actually look at it and use it for cancer response treatment. So you know how you would get a CT scan after so many cycles of chemotherapy or after having some radiation or what have you. And we're looking at CT scans to see if things are shrinking. And it's a viewpoint, right? We can see literally that it's shrinking. We can actually look at that on the molecular level as well. And I'm going to go through that today. And then the last thing is therapy selection for precision oncology treatment options, which would be the profiling. So what's going on with all the mutations within the tumor itself, and can we match a treatment to the mutation so that we have better treatment outcomes, better shrinkage, longer duration of remissions. Next build, Phil. So back to asymptomatic screening, really the question, so what does that mean? It really is just, do I have cancer or not? Right? It's no different than mammogram screening for breast cancer, colonoscopies for colon cancer, PSA for prostate cancer. This is what we're talking about, where ctDNA can play a role in screening. Next one, Phil. In the cancer recurrence, the question becomes, do I need chemotherapy as part of my curative intent treatment plan to prevent my cancer from even coming back? And then the next one, in cancer surveillance monitoring, the question becomes, has my cancer been completely eradicated at the molecular level? Maybe the CT scan says I'm totally clear, but we know CT scans don't capture everything at the molecular level. So how can these types of ctDNA tests look even at like a deeper cellular level? And can we then detect cancer coming back at a sooner rate than what we would see in traditional imaging kind of tools that we use right now? We know that a cancer has to be a certain size before it's even going to be detected on an X-ray, an MRI, a CAT scan, what have you, even to the human eye if you're going to have a colonoscopy. We can actually detect that even before it's at a point where you can physically see it in a diagnostic conventional test. And so the idea is, can we act on that even sooner so that it doesn't have a chance to metastasize and we can get on it more quickly. And then the next one, Phil, in terms of cancer response treatment, the question becomes, how effective has that treatment been in aiming for NED at the molecular level? We certainly know that we're looking for NED at the CT scan level, but even at the, if we've gone back in for more surgery around, the pathological response rate for the surgical margins being, 0. But we still have not understood if there's still circulating cancer cells within our system, even though we've hyperfixated on the area where we've been looking for that treatment in shrinking that tumor, where we can see it in a CT scan or what have you. There still could be circulating tumor cells in our body, and that means that they have the chance to be able to, seed themselves, and then that is like basically the root cause for metastases. And then, of course, lastly, and so my point being is, in the first 4 boxes, that's really about seeing. It's really about taking what we've done with CT scans and MRIs, etc., and taking it to the next level of detection. So think of it this way: when you're diagnosed with cancer, you have a surgery, as an example, to remove it. But then we take the cells to the pathology level to be able to look at it at that molecular level. So that's what we're really doing here. We're taking this to the molecular level so that we can use these types of ctDNA tests to give us much more detailed information, like as if there's a little camera, circulating through your body at that tiny, tiny, tiny little microscopic level, which is very different than the box in orange, which is there's a tumor present and we want to actually micro dissect what's going on in that tumor itself on the genetic and genomic side of things to see what that combination or what that key, what we call oncogenic driver, is there, that's turning on the switch mechanism for that cancer to grow, multiply, proliferate, and then metastasize. And can we match a treatment to that? So those are two very different types of tests, but you can see that they can be used in multiple ways. So we're going to now walk through all of these one by one and give you some examples of how these tests are done. So let's go to asymptomatic screening first. Do I have cancer? Next slide. So screening detection would, our standard fecal occult blood test. We have Cologuard in the US. I'm not sure if Cologuard is up here in Canada yet. And then there's the standard colonoscopy. But now we're evolving to a blood test. And the question is how can they do that? How can they look in my blood and know if I have cancer? So what they do genomically is they've been able to determine a score. And if you have enough circulating tumor cells that hit a score level, that is elevated, they will then flag that to say that you probably have some level of colorectal cancer. The tests are starting to become so sophisticated that we are now on the cusp of actually being able to determine the stage of colorectal cancer that you could have, not just yes or no. So right now, there's definitely tests out there to say, yes, there's something detected here. Some further investigation should be had, but it's evolving even more to not only yes, is there cancer here, we're predicting that this is already a stage 2 cancer, or this is a stage 1B cancer, what have you. It's becoming so sophisticated. But there's more important aspect, I think, too, with ctDNA, especially in screening and detection, and it's that society public health impact. Who wants to go for a colonoscopy? Said no one ever. Said no one ever. Right? Like, Lillian, I love your reaction. I am so with you, lady. But here's the thing: blood test, not so bad, right? So 95% a greater rate of actually people getting properly screened and agreeing to screening if you just do it with a blood test. So and then all those cancers that we can prevent because they've been caught so much earlier, because people aren't putting it off and putting it off and putting off because it's so invasive and I know I'm preaching to the converted. So so there's a big societal impact on this as well. All right, next slide. So I'm giving some examples of actual tests that are out there right now. I must preface, I'm not being a paid spokesperson for any of these tests. These are just some examples to bring to you. They're also may or may not be available in Canada. The purpose of the talk right now is just let's figure out how we apply all these ctDNA principles in the broad spectrum of colorectal cancer, and then if there's additional need to understand around access and things like that, then I can definitely work with Philomena to be able to help provide some of that information. But colon century, I know actually that CRAN has spoken of colon century in the past, because I believe I've been at a talk where we've talked about colon century. But it's interesting actually, because it's a test that is done in the US, but it is actually a Canadian company. So I know the owner, but it's been around for quite a while, and it's one of those tests that says yes, no. right? Yes, you do have something that's being detected and you should go on for further investigation, or no, you're okay, you don't need to go ahead with a colonoscopy. What it does is it finds 2.1 to 4.7 times more colorectal cancers instead of just conventional fecal occult blood testing, or I believe also, no, that's against fecal blood cancers, fecal blood FOB detection. So it definitely has a place, or the concept has a place. Next slide. It's by a company called Stage Zero, just in case you want to have the reference and look those things up for yourself. Its genomics platform is using blood, and it uses mRNA, so messenger RNA, which can also be pulled through the bloodstream. It's typically used for general public screening and those that don't have any cancer symptoms for colorectal cancer. So no blood, no bleeding, no pencil stools, things like that. Typically used for age 45 or older at an average risk for colorectal cancer. So an average risk would mean that you don't have a first degree relative with a history of CRC, and that you personally don't have a history of polyps. So I think as we're getting more sophisticated with our ctDNA genomic platforms, we'll be able to even use these tests for even above average risk patients with colorectal cancer. So again, the goal to avoid is, more colonoscopies than are necessary. Next slide. So with that, we're going to move into cancer recurrence on the prediction of adjuvant setting. And the question we're asking here is, do I actually need chemotherapy as part of my curative intent adjuvant treatment plan in the chance to prevent my cancer from returning? So I know Philomene and I like to call it cleanup chemo. So predicting cancer recurrence in curative colorectal cancer, we're talking about stage 2 and stage 3 A and B. And this is used right after surgery to evaluate the need for adjuvant chemotherapy. Next slide, I think, Phil. Yeah, so the main test that is available, but I don't think it's the only test, but this is one that that your clinicians will know most about, is called the Oncotype DX colon cancer assay. And the genesis has always been used traditional tissue genomic testing. And even though a lot of this talk is about ctDNA, I have to really emphasize that ctDNA is still a relatively new science in genomics. In the scientific world, in the pathology world, the molecular pathology world, the actual tumor tissue is still really the gold standard for what gives us the most reliable information. ctDNA at the moment is not as 100% foolproof as what we get from the tissue itself, the epicenter of itself. But what we're finding through the evolution of ctDNA is that accuracy is getting better and better and better with every iteration of a new test. But I just want to make sure that we don't just jump on the excitement of ctDNA and cast away, tissue testing. Tissue testing is actually still very much the gold standard, but ctDNA absolutely has a complementary role, and it's just determining what is the best approach at the best time for any particular cancer patient in their experience. But here we're looking at David and his recurrence score when he used the colon cancer assay from Oncotype DX was that his result was really low. He did not have a genomic risk of his cancer returning. So he did not have to go through that additional adjuvant chemotherapy and avoided those side effects. And he felt quite peace of mind as well that test was able to let him know that he can go forward in years now and really not worry that that cancer will come back, which is, I think, every cancer's patient's like constant worry. It's always there as part of your new normal. Its genomic profile in terms of, or platform in terms of this particular company uses RT-PCR, and everybody should know PCR now because of COVID. So it just shows that genomics is more than just in oncology. Genomics is in many different areas of laboratory sciences. And I think we've even had a talk about microbiome, and microbiome uses genomics as well. So there's so many different ways to be able to use the genomic platform in the lab. Even for our lab, we're a cancer genomics lab, and when COVID hit and a lot of cancer patients were just at home and not seeing their physicians for months, we pivoted and we started doing PCR COVID testing, because it's the same instruments, it's just a different assay and different panel, but a lot of the process is very similar because it's genomics. It's and so whether you switch over to a mouth swab or a nasal swab, blood test or tumor tissue, it's just the genomic what we call assay or package that's used in the machinery, which is called a sequencer. You can just swap those things out and have very different purposes and uses in healthcare. So this test is, sorry, just go back for 1 second, Phil. So but what the proprietary kind of information is and this is a really good example. So what Oncotype DX has done is they have indicated and found 12 genes that on a regular basis are predictors for recurrence. And so your tumor gets sent down to their lab, and they use their proprietary 12 gene recurrence score to see how many of those 12 genes come up as, bright light or dull and dim. And if you have a lot of bright light, then that recurrence score is high, which means you have a higher risk for that cancer coming back. So you should have that adjuvant chemotherapy. If it's dull and dim and it has a low score, then that means your risk is lower, and you can definitely have those conversations with your oncologist about whether you need to have adjuvant therapy or not. And that's a personal decision. It doesn't say don't have it. It just says this is a conversation that should be had with your oncologist about whether that's something you want to advance with or not. Traditionally, everybody would get adjuvant therapy, so and there was no option for the discussion. I can tell you in Canada that this is currently not available. The data, the Canadian data is, or reviewers are, would like to see the data to be a little bit stronger in that, what's the word I'm looking for? In the assurance that the result is at a higher degree of accuracy. To bring it forward. So Oncotype DX is actually available in Canada for breast cancer, and it has very, very, very high accuracy results, but they have not yet been able to convince Canada and Canadian payers that the results are at a high enough accuracy level to cover the test at a public level. So, and again, I think that's personal preference, to be honest, but that's where we're at with that. So, but it can be accessed by Canada, but it would have to go down to the US. There is a mechanism to do that in a private pay situation. Okay, next slide. Okay, so let's go into cancer surveillance monitoring. Has my cancer completely been eradicated at the molecular level? This applies probably a little bit mostly to our stage 2, stage 3 patients, where we're really looking at that NED. You've had your adjuvant therapy, and now you're in like, follow-up mode. So the next slide, please. And we really want to see about what is going on beyond our colonoscopies. Can we actually detect cancer earlier than our standard, imaging, where that tiny, tiny little molecular residual disease just can't be seen to the naked eye by scanner scope? Should be done in conjunction with CEA. Although CEA has its drawbacks, it does have its positives. It's just, again, we're talking about the level of accuracy. So the CEA level of accuracy is kind of mid-grade, where ctDNA level of accuracy is like above board. So, in combination, they are they're better together. Just hit the advance, Phil. So we've got a couple of different ways there that we are going to think about using ctDNA in this kind of sandwich section. So let's look at surveillance for early recurrence monitoring first, and then the next section we'll go down into that treatment response monitoring. So next slide. So this company is called Natura. They've developed a tumor mutation signature. So this is their secret sauce. They have this, there's X number or X types of mutations that are seen in a colorectal cancer that they're able to detect the cancer in the bloodstream. And when there's a lack of ctDNA in the bloodstream, that indicates that the cancer has not returned. So, we would want to keep seeing that. This does, though, require routine testing to monitor for recurrence. So it's kind of like how you would have your routine colonoscopies. You would also have to do this blood test for routinely over years for the surveillance for recurrence. The genomic platform, as we know, is blood ctDNA, and I pulled this directly from their website. It's the first tumor-specific assay for truly individualized cancer care. So it's a custom-built assay based on the unique mutation signature of each patient's tumor, which identifies and then monitors the tumor mutations at the source. So they actually need a piece of your tumor tissue first. What they do with that tumor tissue is then they apply it to their mutation signature, and now they know what your assay is and your tumor profile, right? Your mutation profile. And from there, they can detect that profile from blood tests moving forward after that. So after they've designed your personal assay, then your blood is then taken to be able to accurately monitor for that actual cancer tumor that they started their original profile of your cancer with, using the original tumor tissue. Next slide. So still sticking with Natura here, with their model of how they do this for this recurrent test accuracy evidence is at an 88% accuracy level. So that is a far better accuracy level than CEA. Absolutely. Here's the thing. Part of the reason why I don't think it's quite come and hit the Canadian market just yet is because Canadian market tends to prefer accuracy levels at 95% or higher. But in the context of what we currently have, CEA is very limited. I'm trying to really be politically correct with my adjective. Very limited. So 88% is pretty gosh darn amazing compared to CEA, which is literally archaic. But it's what we've got. So we don't want to throw out the baby with the bathwater, but let's also embrace improvements, right? So anyway, but just to let you know why there's been some hesitation with the Canadian providers, because it's not quite at that level, especially when we're talking to have a colonoscopy or not to have a colonoscopy. Physicians just like to err on the side of comfort and of what they know, and caution. Because the nice thing about a colonoscopy, sorry, bad word. The advantage of a colonoscopy is that if there happens to be a polyp there, then at least that can be snipped and we can move on, right? And that's not going to go anywhere. And that we've just cured cancer, if colorectal cancer, we've snipped out those polyps. Okay, so next slide. Sticking with the same company, actually, their special technique or model can also monitor how well you are responding to treatment. This can apply in both the adjuvant setting and the metastatic setting. So let's go to the next slide. So here's the thing. We're looking at, and you can hit the next button, Phil. So we're looking now at treatment response monitoring. If you have when they do the test and they figure out from your tumor cells, your actual solid tumor cells, this blood signature, there's going to be like a high detection of cancer cells, right? And then as you have your tests, your blood tests, hopefully when you're having treatment, we're going to see that the quantity of those ctDNA cells are going down. And that would then be suggesting, and we would be seeing on a CT scan that the tumor is actually shrinking and the treatment is being successful. In the case of adjuvant therapy, so say you had a high risk of your cancer returning, so you did have adjuvant therapy. There's actually nothing left. We've cut it out, we've radiated, like there's nothing there for us to physically be able to watch to shrink like we can see in the metastatic setting. So we give you X number of cycles of adjuvant curative therapy, but we think that that's enough. Most clinical trials have determined that that's enough, but we know that that's not enough for some people because some people still recur. So we need to look at a molecular level to be able to determine, is there still something circulating in my blood cells that are just not being picked up on conventional screening or CT scans? So I really know I'm molecular NED, not just diagnostic imaging NED, right? Huge difference. So let's see how many cancer cells by volume on the molecular level are actually present after you've had a standard course of treatment. And let's see if in fact that standard course of treatment was okay for you, or if in fact you might need a little bit more until you are finally at that molecular level of NED. Next slide. So this is how it's done. So they track your circulating cancer cells over time and require routine testing. Does everybody see my little arrow? I'm not sure if. Yeah, okay, good. All right, so let's say we're here at the top. Blue dot means we can see ctDNA in your bloodstream, which means you have still cancer in your system that's sloughing off these dead cells that are being picked up in your bloodstream. And this is at a pretty high level. So we can see there's quite a lot of cancer, a lot of going on here. Then you started to have treatment. Ooh, look, treatment. Okay, we are starting to kill off those cells. There's not as many to be collected. The signature is weakening. We're seeing less and less. Next test again, we're seeing fewer ctDNA positive cells there. And then look, now here from June to January in 6 months, we actually see that there are none. There is no ctDNA cells to be found. And then we're continuing on a 4-month schedule to take that blood test to confirm that there is still 0 ctDNA. You are molecularly NED, and that is in fact continuing on as you have each blood test to monitor for that surveillance, for that treatment response. This can also be used in metastatic setting as well. In colorectal cancer, there's a lot of debate about chemo holidays, stop, start, things like that. But there's also an anxiety about stopping and starting, and does it mean that my cancer is going to come back really bad, or can I at least know more than just a CT scan that molecularly nothing is starting to spike or regrow? Because basically we could see then the reverse, that this could be the chemotherapy brought it down to a molecular NED, but then in April, oops, we're actually maybe imagining, if you imagine a blue, circle here, we're starting to detect, but your CT scans might be completely clear. So we would then have to have a conversation with your doctor around, okay, something's cooking. And sometimes we can see that in CEA before we see that on a CT scan. Sometimes we can see that in elevated liver function tests, but really they're more of a side effect, like a domino effect of the cancer regrowing, as opposed to getting right to the tumor level and understanding the behavior of what's happening with the growth of the tumor level. So this can give a little bit more reassurance around chemo holidays during the metastatic, period, or if you've had, say you've had, some really severe side effects. I mean, oxaliplatin, no thrill. It's it's nasty. If you need if you've just had your fill like your limit, then you can use this method instead of worrying that, oh my gosh, I had to stop my treatment early, and what's that going to mean? This at least gives you a little bit more information, hopefully to detect things earlier, so you can pounce on things earlier.
So Shania, I'm sorry to interrupt at this point in time, because I recognize that we were going to save questions till the end, but this might be a question that's literally floating around in an awful lot of minds at this point.
Sure.
If you have no radiographic evidence to support, let's say, an elevated ctDNA rise, for example,
Mm-hmm.
or level, pardon me, level, how do you sort of impress upon clinicians to do something about that elevated ctDNA number when you have no radiographic evidence?
Yeah, and it's a very good question, and it's a question they still can't even answer. But it's about, the more we do this, the more they have to then come together as physicians to say, you know what, this is a new tool, and we need to start to evaluate how we use these tools in our standard practice. And do we jump on it right away, or do we watch and wait? So often right now, if it is in the curative intent situation and there's a potential that you could cure it, they would probably, I think, jump on it. The challenge is where do you jump on it? Yeah. So are they thinking that this is just a situation where there's micro disease and you need a few more extra cycles of adjuvant chemo? Or is this metastatic disease where we need to see where it is and we'll keep a really close eye on where it is, so then we can try and cut it out, sooner and go for surgical, sort of treatment plan, yeah. Or look at the original tissue and do genomic profiling on it to see if there's an oncogenic driver that would then maybe initiate some treatment that's tailored, right? Mm-hmm. Or real traditional is, let's just see when you have symptoms. If you're doing okay for now, yeah.
That was actually going to be my follow-up question. So for our stage 2 and stage 3 patients, especially our rectal cancer patients, who are not symptomatic, like not symptomatic at all, and for whom the CEA is not a good indicator, like
totally.
This seems to be the trend in our rectal cancer patients. CEA really isn't a great indicator. Mm-hmm. And they're not symptomatic. And ctDNA seems to be, for those who are accessing it in the US, like our counterpart patients, for those who are accessing it, there seems to be an elevated ctDNA level, and there is no radiographic evidence to support a correlation there. Mm-hmm. Clinicians are not necessarily acting on it.
Yeah, that's right. Because there's no clinical research to guide them in that, right? So it becomes a question of, is this a systemic problem that we are concerned about, that we would want to use chemotherapy with a little bit more cleanup chemo? Yeah. Or is this a local situation where maybe just a little bit more radiation in the general zone is something that's needed? And that needs to be right now it's a personal discussion with your oncology team, but we really do need to have better research on what would be the treatment algorithm, knowing that we have molecular disease without radiological involvement. And I'll tell you, it's done in hematology, right? This is not new. We're stealing ideas in solid tumor from hematology cancers. This has been done in blood cancers for decades. Well, 15 years. So there is precedence and there is experience, but the problem is the hematology oncology group they're quite separate from the solid tumor group, academically speaking. Clinical trials are not done in combination that way. So we need to call out that oncologists have a lot to learn from their hematology oncology counterparts. and work to, you know, some really good clinical trials. So I would get on a study for that evaluation, but at the moment, though, it is definitely a personal discussion if there's additional treatment to be considered. But you're absolutely right about CEA not being very effective for rectal cancer, because a lot of rectal cancers, they're just completely biologically different than colon cancer. So,
yes. And this is really important. The points that you're bringing up are really important. And CRAN is absolutely willing to advocate on behalf of these patients. And it's just another piece of the puzzle that helps deliver a really good picture about what's going on inside the human body biologically in terms of the potential reoccurrence. So thank you. Sorry, I won't say anything.
No, it was a great question. I mean, physicians are a little bit handcuffed to go, well, where is it? All right. Like if it's a physical location, I can send you to a surgeon, or if I can send you to a radiation therapist. Is it only in one spot that it's going to recur, or is it in other spots? It should, at the very least, it should mean if you were getting CT scans every 6 months, you should be getting them every 3 months. At the very least, you should be getting your surveillance on the diagnostic side a lot more frequently. And then as soon as something is detected in 3 months, you know, you shouldn't have a gross experience there, that in terms of the cellularity of the duplication time for the cells to divide and create something very concerning. So, and then there'd be something at least for them to say, okay, now I see it and I can send you to surgery, or I can send you to radiotherapy or what have you. So at the very least, your surveillance on the diagnostic side should be more frequent.
Okay, thank you.
Okay, so next slide. And we come to the end of our talk. So the therapeutic selection for precision oncology treatment options, and I've talked a couple of times with this group around that. And, you know, really, what is your tumor profile? What's the secret sauce of your genomic tumor drivers that are causing that cancer to come back, causing that cancer to mutate, causing that cancer to metastasize? And can we get you a treatment that is matched to that particular mutation, or otherwise called biomarker, otherwise called alteration? So again, if you advance the slide, Phil, we're going from the difference between seeing, where we see diagnostic, versus really like profiling to what is causing the cause and effect of cancer. Next slide. So I've showed this graphic before. And so what we do in profiling at the tumor level is we look to see, are you somebody that has a purple star tumor? Then on your DNA strand as a mutation, then we'll give you the purple star medicine. Or do you have a yellow chevron mutation? Then we would give you the yellow on your DNA strand, then we would give you yellow chevron medicine. So it's very targeted, right? Otherwise, historically, we would just give everybody FOLFIRI or FOLFOX plus or minus Avastin, right? So this way we're getting very specific to understanding what is happening, particularly for you. Next slide. So initially, the clinical purpose really was founded on tumor tissue, still remains the gold standard for depth and accuracy. Now we're evolving into ctDNA, and it's actually really especially useful when tissue is not available. There's a lot of reasons why tissue is not available. And so when tissue is not available, the first thing that we have to do is say, can you go for a rebiopsy? Oh yeah, said anybody, I want to do that, never again. Right? Like it's right up there with like, yeah, really want that extra colonoscopy, not. So, you know, sometimes tissue is not available because it's been quite some time since you've had cancer, and your original specimen is actually degraded in the library that is held in the pathology lab. Sometimes the tissue sample is been overused by pathology, that what's remaining, there's not enough tissue for us to be able to extract enough DNA and RNA. And then we have to go back for a rebiopsy. Sometimes they put it in the wrong fixative to store it for long term, and the fixative is what's caused the cellularity to degrade, and we can't use it for ctDNA uses. There's a lot of reasons. Sometimes people are diagnosed on peritoneal fluid and instead of a solid tumor, and you can't, we're not advanced yet enough on the tissue side of genomic profiling to use that liquid type of aspect. So we would need blood. So there's a lot of advances, even though it may not, even though ctDNA in this particular aspect may not be as specific and accurate in the depth of accuracy as we get on tumor tissue. So next slide. So here are options for genomic profiling, and full disclosure, this is where OncoHelix can be a support in the Canadian market. So we have tissue testing, which is there's two different things. We have a comprehensive genomic profile and we have a focused profile. A comprehensive genomic profile is at least 100 genes plus, and it includes key differentiator. It includes RNA to be able to determine fusions. This is why it's a gold standard for the depth of sequencing and the accuracy over ctDNA. Finding those fusions is tricky business, and it is a lot more clearer if that fusion exists or doesn't exist when you use tissue. So for example, you could have a ctDNA comprehensive genomic profile of 100 plus genes, and a fusion comes up negative, but you could have the same tissue tested instead of it being blood-based, but tissue-based, and in fact, that fusion could be, in fact, there. That's the level of depth and accuracy that tissue gives you in more accuracy, more confidence. So that's why it's still the gold standard, but realizing practically that can't happen for everybody. So I always tell patients, go for tissue CGP if you can, if you can. But if it's not practical, then we have other options. You had a question, Phil?
Yes, sorry, Shania, is it just fusions that essentially demonstrate that lack of accuracy? What about
so fusions are the biggest, I don't want to call it problem, but the biggest kind of swing factor. But it is also true for other DNA genes as well. So things are tested at different depths of levels depending on the genomic test profile. And so when you get to the tissue test, you're getting it like as close to the level as you can. When you're talking ctDNA, because you're getting it from the actual tissue. When you're talking about ctDNA, well, it's cells they're dead cells that have sloughed off the tissue and circulated through the system. So it's almost like it's gone through the telephone ring, right? And then we're collecting it. So it degrades a little bit. That's why it's just not as accurate. It's sort of a second degree relative to the original tissue. So that's why you don't get as much of that confidence in. So you could have somebody who is EGFR or KRAS negative on a ctDNA test, but is actually positive on a tissue test. That can happen. Yeah. Okay, so the next, we'll advance to the next slide, but let's talk about our blood ctDNAs because, they're not as accurate, but they're still a very good option if we need to go there. So I was telling you about a focus profile versus a comprehensive profile. Focus profile is about up to 50 genes. We call it focused, practical, pragmatic, actionable. These are all the same terms that are meaning the same thing, meaning we actually have drugs that are commercially available for finding a alteration or a mutation. When you do 100 plus gene profile, we could find all sorts of genes that are mutated in your tumor, but there may not have been a drug that has been developed yet for that. So a focus panel really specifically looks at, okay, what's in the here and now on the commercial side of things. doesn't necessarily cover off all the things that are happening in advances in clinical trials. So if you're really into the research and development, what is cutting edge, what is coming right around the corner in the newest drug treatments for precision oncology, then the tissue is a good way to go, at least in terms of access in Canada. With a Canadian partner, which would be OncoHelix. We are the only partner in a direct-to-consumer model to be able to provide that access. There are other research access models within the rest of the country, but if you don't apply for that research, or if the research program is closed, hasn't become an option to you, then OncoHelix can be a potential solution. So then the next advanced slide is, I'm sure everybody has heard of Foundation Medicine. So they have both. They have a comprehensive tissue panel and a comprehensive blood ctDNA panel, 100+ genes. So, you can have your blood test taken, it goes down to the US, and you can have your profile done again. And again, we talked about that kind of second degree cousin. It's still a blood ctDNA, so it's not as accurate, but it's still a very plausible option if there's challenges to be able to otherwise have a comprehensive genomic profile using tissue. Advance the slide, please, Bill. So OncoHelix in Canada, and one more time, offers both a comprehensive tissue panel, which is actually the most routinely used panel in the world, and we use a ctDNA focus profile called Follow It, which is a Canadian invention from a cancer pathologist based in British Columbia, and is actually used a lot in Australia. So you may have some Australian counterparts that are very familiar with Follow It. It's used very routinely there. So we are able to, our lab is able to offer both of these types of tests, and we can talk about in your Q&A if that's something that you guys would like to understand, is how do I choose like which one over the other in my particular case. We can definitely talk about that, and you can always email Philomena or myself as well if you're thinking that you might like to do this, and in conjunction with your oncologist, and you're just trying to kind of navigate the different options that are out there. One is more expensive than the other, and sometimes it's even just, I can afford this, so this is, at least I'm going to do this, and that is perfectly okay as well. The ctDNA Connexia Follow It with the focus panel is less expensive than the full genomic profiling panel. Okay, so next slide, I think, is my wrap-up slide. Yeah, so here we are, the spectrum of colorectal cancer. It depends where you want to use ctDNA in this spectrum, in your family, right? So if you yourself are a patient, but you want your family now to really be screened at a molecular level, then you could, think about molecular screening for detection. It's a consideration for whether you should have adjuvant treatment or not. If that's the case, it's a one-time test, because most of these tests you do have to pay for. They're not covered yet by the Canadian government, and maybe not even available in Canada. You have to go to the US. If you've had your adjuvant treatment and you're on surveillance to see if it is going to come back, then that would be a routine test that you would repeat with your CT scan or a colonoscopy, depending on what your follow-up plan is. Or maybe it's appropriate for your treatment course to see if there's any cells left, and that see that they're coming down and that they're staying down, and that you're a molecular NED. Again, you have to continue on the repeat of that testing during your surveillance period. And then on the last slide, what we were just talking about, it could be actually deciding what's the best treatment for your cancer to be able to specifically, by precision oncology, turn off the biological driver that is making your cancer grow and activate. So I'll take question. Last slide is questions.